Hello my dear children of class 12 science. Now we'll start a very short chapter under unit number 8. Okay, and the chapter that we deal basically with the nucleus as was discovered by one of the scientists called Rutherford. Okay, and the discovery of nucleus you learn in the previous chapter also, atom and origin of spectra. And the chapter that we are going to do or deal is called nuclear structure. A very short chapter. Okay, now we do only the important topic for your examination. Okay, and this is one of the chapter, as I said, under unit number 8, atoms and nuclei. Okay, now we start this chapter especially with the topic that we will learn is called composition of nucleus. Composition of what? Nucleus. Since the chapter name is nuclear structure, means we deal basically with the nucleus. Okay, now nucleus, as you know, it was already discovered by the scientist called what? Ernest Rutherford. So Ernest Rutherford was the scientist who discovered nucleus in the year 1911. So discovery of nucleus was done by Ernest Rutherford. And this discovery which was done in the year 1911, okay, discovery of what? Nucleus. In the year 1911, and this discovery of nucleus is actually done by one of the most important experiment which was performed actually by the two scientists. Actually, they were the students of Ernest Rutherford, and the name was Geiger and Marsden. But their experimental observation was further explained and understood and made a conclusion by the Ernest Rutherford only. Okay, and the name of the experiment that you learn is called alpha particle. Yes, alpha particle. What experiment? Scattering experiment. Scattering what? Experiment. So this is the experiment you learned in the previous chapter. That is called atom and origin of spectra. So Rutherford alpha particle scattering experiment showed that the whole of the positive charge, yes, you learn like this only, the whole of the positive charge and almost the whole mass of the atom is always concentrated in an extremely small space at the center of the atom, and that small space actually called as the nucleus of the atom. So nucleus of the what? Atom. So the nucleus of the atom is nothing but a very small space of the whole of the atom, okay, concentrate of the pool of what? Positive charges. The whole of positive charge, okay, and whose positive charge and the whole mass is always concentrated at this space, and this space is called nucleus. So from this experiment we saw the discovery of what? Nucleus. Discovery of what? Nucleus. And nucleus is the central part of the atom. The central part of the what? Atom. So as for the experimental observation, okay, even the nucleus has a certain diameter. So the diameter of nucleus, okay, was almost found in the order of 10 to minus 15 meter. So nearly 10 to minus 15 meter. The 10 to minus 15 meter means almost equivalent to 1 Fermi. So Fermi is also one of the unit of length or distance. Very small diameter. And this diameter is very small as compared to the diameter of the atom. Okay, diameter of the what? Atom. Now, even with this experiment, you learned that the electron revolve around the nucleus. Yes, electron revolve around the what? Nucleus in a definite orbits. And the negative charge of all the electron is equals to the positive charge of the nucleus. Means when a nucleus is formed, it is simply a seat of what charge? Positive charges. And when electron has a negative charge, it always revolve around the what? Nucleus. In what? Different orbit. So these are the electrons which revolve in a definite orbit. So for a given atom. Okay. And the number of electron as a negative charge which present in an atom is equal to the number of protons, the number of positive charge, present in the what? Nucleus. That's why you know that atom as a whole is considered as electrically neutral. So why atom as a whole is electrically neutral? So atom as a whole is what? Electrically what? electrically neutral. That means the total charge or net charge in an atom or normal atom with the atom which are not in excited state or normal atom is always 0. That's why the atom is usually a what? Has a what? A neutral charge. Atom as a whole is usually a neutral. But in which state? Normal state. Now after the discovery of this nucleus with this experiment in the year 1911, so in the year 1919, so there is another year how much? 1919, Ernest Rutherford only discovered the particle, the positive charge particle, which is actually present inside the nucleus of an atom, and this particle is called proton. So that means Rutherford even discovered what? Proton. Discovered proton. So proton as a positive charge. So with the discovery of proton, okay, in 1919, he said that the mass of proton, see, the mass of proton is equals to the mass of hydrogen nucleus. The mass of proton is equals to the mass of hydrogen nucleus. The mass of one proton is equals to the mass of hydrogen nucleus. Hydrogen nucleus. Because hydrogen usually consists of only one only one electron and only one proton. And that hydrogen, the mass of proton is equal to the mass of what? Hydrogen nucleus. Because in hydrogen nucleus, okay, so when we talk about the hydrogen nucleus, the mass of proton is equal to the mass of what? Hydrogen nucleus. Now, and the charge of proton is equal to the charge of electron, but with what side? Positive charge. That's why E is the charge of electron, where P is the charge of proton, but the proton charge and electron charge have same magnitude. See, the magnitude is how much? 1.6 in minus 19 coulomb. But only difference that proton is a positive charge, where electron is a what charge? Negative charge. That's why I write down P equals to plus 1.6 into minus 19 coulomb. And electron is a negative charge, and I write down as minus 1.6 into minus 19 coulomb. So remember this, children, the charge of proton is same as a charge of electron. But proton is a positive charge, where electron is a what charge? Negative charge. Now when we now compare the mass, it's not only this electron proton has a charges, this particle has what? Mass also. Now if we compare the mass of the electron, okay, the mass of the what? Electron, the electron mass is very negligible as compared to the mass of what? Proton. The mass of electron is very negligible compared to the mass of electron. And for information, the mass of electron is really 9.1 into minus 31 kg. Okay, mass of electron is this much. Okay, whereas the mass of proton, okay, where the mass of proton is almost 1.67 into minus 27 kg. So this makes the mass of electron is almost less compared to the mass of what? Proton. Means electron is usually lighter charge particle as compared to proton. So in the year 1919, as for the discovery of this proton and electron, which was done by Rutherford, it said that the mass of the atom, that means the atomic mass, is usually comprises by the mass of what? Proton and the mass of electron. But this was not true, because this make a theory or hypothesis considering that the nucleus is comprises only with proton and electron. Okay, and this was like a hypothesis called proton-electron hypothesis. But with this hypothesis considered by the Rutherford, okay, so number of what difficulties that has to face, okay, with this consideration. Okay, so under these circumstances, in the year 1900, I'm writing in the year 1932, almost long time back, okay, almost how many? Almost 13 years after the discovery of what? Proton, the scientist whose name was James Chadwick. The scientist's name was what? James Chadwick. Okay, James Chadwick discovered the particle, another particle, but is a neutral particle that is also present inside the nucleus other than the proton, and that particle name was neutron. So neutron. So the discovery of neutron was done by James Chadwick. Discovery of neutron, discovery of what? Neutron was done by James Chadwick, and in the year how much? 1932. So neutron was discovered, okay, by James Chadwick, and he considered that this is an uncharged particle. It is an what? Uncharged particle. Okay, so neutron is basically considered as what? Uncharged, or we also call as what? Neutral particle. Means this is the only particle present inside the nucleus which does not carry any charge. Okay, is a neutral particle. Okay, now with the discovery of nucleus, the proton electron hypothesis, which was considered by the Rutherford, which completely failed. Okay, completely what? Failed. And this is especially for the nuclear structure, and especially talking about the mass of the atom. Because in proton electron hypothesis, okay, the mass of the electron atom is actually comprises by the mass of proton and electron, but that is not true. That was not true. Now electron is also present inside the what? Inside the nucleus, but electron does not carry any charge. Electron does not carry any charge. Okay, that's why this neutron, which was discovered as a neutral or uncharged particle, okay, whose mass is nearly equals to the mass of proton. So mass of neutron is nearly equals to the mass of what? Proton. So whatever number of protons are there, okay, they are the number of neutrons, but the mass of neutron is 1 neutron equals to the mass of what? Nearly to the mass of proton. And this property of neutron combined with the property of proton, okay, to fit into the nucleus. That means with the discovery of neutron, it was come to know that inside the nucleus is not only the positive charge which are present. The nucleus is not only seat of positive charge present. They are the uncharged particles which are also present, and that uncharged particle are nothing but neutrons. Nothing but what? Neutrons. That's why now we assume that the nucleus is comprises of proton and what? Neutrons. Protons and what? Neutrons. And this nuclear particle, protons and neutrons, are also called nucleons. So remember this, children. Protons and neutrons, which are present as a nuclear particle inside the nucleus, are also called nucleons. They are also called what? Nucleons. So with this discovery of neutron, so children, James Chadwick only measure the atomic number. Atomic what? Number. And atomic number, as you know, is marked by symbol Z, is the number of what? Protons. Yes, you have learned this definition. So number of protons present inside the nucleus is actually equals to what number? Atomic number. And with this statement only, we come to know that there is a what number? Mass number. And also called atomic mass number. And total number of protons and neutrons equals to the atomic mass number. That means mass number is given by total number of protons and neutrons. So inside the nucleus, the number of neutrons are present, the number of protons are present, and total number of neutrons and proton measure the what number? Mass number. This is also called atomic mass number. So symbol of atomic mass number is given by A, and symbol of atomic number is symbolized by Z. So you have learned this already in the lower class also. Okay, atomic number. Okay, so in this way, the discovery of the neutron makes the complete clear concept of the composition of particles inside the nucleus. So nucleus, as for the observation which is seen, comprises of two particles. One is called positive charge particle, that is called proton, and another is called uncharged particle, that is called neutrons. Okay. And even children, you know that the place of any element, the position of any element in the periodic table is also decided by the what? Atomic number. Decided by the what number? Atomic number. Okay. But electron is the only particle which revolve around the nucleus. Okay, as a negative charge, it revolves around the nucleus and in a different what? Orbit. So this explains the composition of nucleus. Now in the next YouTube video, we discuss about the nucleus size, the nuclear radius. Okay, these are the topics that we are going to discuss in the next YouTube video.